This is the second video for the double angle formulas. This would have been January 11th or January 12th, unless you were 3B and 4B, in which case this would have been January 17th. Yep. We looked at deriving the formulas. The formulas I put here, we saw how they would be used, how they would work. Now we're gonna solve two equations together. I'm gonna let you try the third one, which is more of a challenge problem. But this is their main use, right? So this is similar to what we did last class, or like maybe not last class. Back up. Last semester, we're actually gonna use like different identities to solve. So here we're trying to solve this equation where really this should be an x, theta doesn't matter, lies between 0 and 2 pi. And what might be a good strategy to start with is if we get 0 on one side. So in class we actually did this to start by adding cosine to each side. This would become 2 cosine plus sine of 2x equals 0. These would go away. Now we get to a roadblock. We don't really know what to do here. We can't simplify. There's no identity that says 2 cosine plus sine of 2x. However, using the double angle formula, what we can do is treat this as an identity. We can say that since sine of 2x equals 2 sine of cosine x, all right, we have a sine of 2x here. That's equal to the 2 sine x cosine x. So what we can do is keep the 2 cosine x. Because this quantity is equal to this quantity, we can replace the sine of 2x with 2 sine x cosine x. And I have color coded for a reason. So what's underlined in black is what's on the left hand side. Underlined in blue is what's on the right hand side. And we can do this because these two quantities, what's underlined, those two quantities are equal. Now, this might not help us in all situations. We actually solved equations. Let's do this on the side, right? We solved equations that look like this. Sine of 2x equals 1. We saw where sine would equal 1. That would be pi over 2. And so what we would say is 2x equals pi over 2. And then divide. But here, we wouldn't be able to get the sine of 2x on its own because of this 2 cosine x. However, hopefully we can notice now that you have, if you look here, it might be tempting to combine the cosines, but we can't do that because they're not like terms. What would be analogous here is if you replace cosine with x and sine with y, we would end up with this, like something that's similar to this, and these would not be like terms. So what do we do? What can we do? Well, hopefully you notice that we have a 2 in both terms and a cosine in both terms. So if we have any type of quantity that occurs in both terms, what we can do is factor that quantity outside of our expression. And so if we do that, what this would become, we would factor a 2 cosine x out, and in doing so we are reversing the distributive property. So by factoring 2 cosine x from this term, if we factor everything out, what you would be left with is 1, because when you distribute, 2 cosine times 1 would be 2 cosine. Similar thing here, we factored a 2, we factored a cosine, so we would be left with sine x here. If you don't believe me and you need extra help, factor, or distribute 2 cosine times 1, 2 cosine times sine. That would give you this. So these are equivalent. Now we have two quantities multiplied by each other. Those two quantities equal 0. So this quantity, we can set this equal to 0 and solve. Since they both, two things multiplied together equal 0, then we know that at least one of those things equals 0. So we can set both of these equations equal to 0. And now we can solve. Divide by 2 here. Subtract by 1. Now, where does cosine of x equals 0? On the unit circle, where that would be is pi over 2, and x equals 3 pi over 2. So that would be our solutions from this side of the equation. And then here, where does x equal negative, sine of x equal negative 1? That would be 3 pi over 2. Now, one little tidbit here, because you have 3 pi over 2 here and there, you only need one of them. So if it were to come up on an assessment or like a challenge exam, how many solutions does this equation have? It only has 2. You don't need to repeat this solution twice. Let's talk about the next one, and then I'll actually try to let you solve the rest of that on your own. Here, again, if you want to try to get 0 on one side, it's a good place to go. Good place to start. Subtract on both sides. Again, roadblock, right? We have sine. Oh, that should be a beta there. This wouldn't be sine squared because this is different quantities within our side of our function. But again, what we could do is replace it with our double angle formula. So our double angle formula here would become 2 sine beta cosine beta due to the double angle formula. This sine beta still stays minus cosine beta. Now, again, they don't simplify. We can't combine like terms because this is not alike with this one. But hopefully I don't have to say it, right? Hopefully you notice both terms have something in common. What do they have in common? Cosine. Hopefully you either said it or just thinking it. Now, if we take cosine, I'm going to do like a step here. If we take cosine away from here, we have 2 sine times sine, but we know that sine times sine is just sine squared. And if we factor cosine away from here, we would have 1. Now, here's a reason that factoring is such a good thing and why it's a beautiful thing that helps us in mathematics, is we have something times another thing. Those two things multiply together equals 0. So we can set this equal to 0 and solve. I'm going to set this up here equal to 0. And solve. Oh, sorry. Here we just did this piece. Beta equals pi over 2 and 3 pi over 2. We just solved that. Here, I'm just going to do the inverse operations quickly. 2 sine squared beta equals 1. Divide by 2. And then we would take the square root. However, if you take the square root of both sides, you have to have positive and negative. Positive and negative. And the way we take square roots of a fraction, square root of your numerator, which would be 1, square root of your denominator, which is square root of 2. And then we rationalize. Or as Mr. Richardson would say, we rationalize that mug. And now we look, where does sine equal positive and negative square root of 2? On your unit circle, that would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. If you have questions, pause, rewind, get the unit circle out. If you don't, you're going to be lost. You're going to be lost without a unit circle here. So do that. But if you have questions, ask me. Now, I would highly recommend this one. You're going to use the cosine double angle formula, but you're also going to need this. Give you a hint. You're also going to need this here. And I'll even get it in the form that it might help you. If you subtract sine squared this form of our identity might help you solve this equation, this form here. See if it does. If you solve it correctly, what you should end up with is x equals pi over 3 and 5 pi over 3 from one side of your equation, and x equals pi from another. Give it a shot. That problem's a little more challenging. You end up with a quadratic, but I think you could probably solve it. If not, ask questions. Hopefully I answer it.